This is Tony from Historic American Homes. We are back with part 3 of our Big Living in a Small Home. This home design, inspired by mid-century modern design, is using SketchUp and layout. Today we're going to talk about the roofs, all about flat roofs. These are the topics we're going to cover today. First, flat roofs aren't flat, and structure, insulation, and finally, waterproofing. I'm not going to go deep into any one of these. I'm going to discuss a few of the options I considered for each in this design, but there are many other options which I'm not mentioning here. The reason is that would make the video very long, and I thought instead of focusing on just one of these topics in a video, I'd like to show how all 4 topics fit together. Let's start with flat roofs aren't flat. We never want to make our roofs dead flat. For a start, they won't stay flat. Over time, roof structures will sag ever so slightly, and that sag will be a place where water will collect. When the water collects there, that's going to add weight to the roof, which will cause it to sag some more, which will make space for more water to collect, which will add more weight, and you end up with a cycle that results in roof failures, complete collapses. Roofs have indeed collapsed because they were made flat. So a roof should have a minimum slope of 1/4 inch per foot. That means 1/4 of an inch of drop for every foot of horizontal distance. That's the bare minimum. That is acceptable and works well if you're using a very properly applied high quality waterproofing membrane such as TPO or EPDM. There are also vinyl membranes, and then there's various asphalt types. We're going to be looking at 2 types in this video further along. Next question with the slope is whether you do it with the framing of the roof or with the material on top of the framing, and we're going to look at that when I discuss the structure. First, I just want to give you a little view here of our project, a little reminder. We've got 2 different situations we're looking at. We've got the block on the left, which is the bedroom wing, and which has got a parapet around it, and the block on the right, which is the great room, which does not have a parapet. And so we're going to use 2 different approaches to finishing off this roof. We've also got a couple of penetrations where there will be skylights. I have not drawn the skylights in yet. But if you look down there, you can see the 2 bathrooms that are down there, because these bathrooms do not have exterior walls, so I wanted to get some natural light into them with skylights. We've also got a scupper over here, which is where the water will drain out of this roof that has parapet around it. That scupper drains into a downspout. And then for the main roof over the great room, we have an open edge eave, so that means the water can drain freely off the eave. It's less inclined to clog up. A scupper can get clogged, so I'm going to make this a very generous sized scupper. These eaves are open eaves, so they will drain into a gutter, which you see here, that gray metal there, and then the gutter will go down downspouts. In this case, I'm using a rain chain, and I'll talk about rain chains a bit at the end of the video. On this side, we get an overhang. This is the south side, so that overhang will help to provide a little shading in the middle of the day so that the house doesn't overheat. So these are the conditions we're looking at for this design. So let's talk a little bit about roof structure. We've got 2 approaches to doing this flat roof, and I will say that I decided at the start that I would have the roof framed dead flat, dead level, no slope. So the framing will be flat. Now the options are that the framing could be sloped, and then that provides a sloped surface for your roofing, waterproofing materials on the top. That's already sloped because it's taken care of with the framing. So it makes the roofing and waterproofing stage perhaps a little simpler, but it has some disadvantages. It requires that all of the wall framing incorporate the slope as well, and it means that your ceiling underneath your sloped roof is also sloped, and you may or may not like to have that ceiling sloped. If you don't want it sloped, if you want it flat, then you have to do something underneath, so you're adding work. So in general, I like to try to keep the framing package very simple so that the framers can work square, cut their pieces at right angles. It all goes up fast. There's less chance for mistakes. And then we get the slope for the actual roof drainage on top of that in other ways, which we'll look at. So we're going with flat, dead flat framing. And then we have two choices. We could frame the roof or we could use what are called SIPs. We'll take a look at SIPs first. SIPs stands for Structural Insulated Panel System. And this nice little picture here from one of the SIP manufacturers called Acme Panel, they've got this nice little image that shows the difference between SIPs and framing. In this case, they're showing it for a wall, but basically the same thing applies for roofs. With the typically framed wall, we have wood framing with studs and plates, and then the whole thing gets insulated inside, and we get a plywood or oriented strand board OSB surface applied to the outside face to provide structural lateral strength structurally. Now, this is easy to do. It's relatively inexpensive. The labor is on-site, which can be a little more expensive than labor in a factory. The labor on-site can also have to deal with difficult site conditions, which can be avoided in a factory. But the biggest disadvantage of the framed approach versus a SIP is that at every stud, you have no insulation. So you've got these cold bridges where your uninsulated surfaces are a problem. So one way to avoid that is to use a SIP panel, which is two sheets of usually oriented strand board, or although you can special order them with plywood. And then the sheets are like a sandwich. They're like the slices of bread for a sandwich, and in between them you have rigid foam panels that are glued to the sheets. These are surprisingly strong. They are stronger than a house requires. So there's no issue in terms of structure for using these in a house. They work just fine. They have the advantage of having none of these studs causing cold bridges to the outside. And they are also made in a factory setting. You can get them, if you send your plans to a SIP manufacturer, you can get them with holes cut out already for window openings. So the work on the job site can happen a lot faster, and sometimes that results in a cost savings. The SIP panels themselves are more expensive than the materials you'll pay for a framed wall, so it can be a trade-off in terms of the costs. You just have to evaluate what works best for your situation. In this case, we're only using the SIP, we're only considering the SIPs as a possibility for the roofing, and I've actually opted to go with a framed roof for reasons I'll get into. But I wanted you to see these SIP panels. I'm going to show you one or two other manufacturers that make them. This is Premier SIPs. I'm not sure if they're the largest SIP manufacturer in the United States, but they're certainly one of the largest and very, very reputable. SIPs first started being used most commonly as a way to sheathe timber framed houses, and typically in New England where you were dealing with really extreme cold weather. In that case, the SIPs weren't really structural in that there was a timber frame carrying the major loads, but you can see that these SIP roof panels that they're putting in, you see one up here, they span quite a distance between these trusses, so you really can cover quite a length with a SIP panel. You can see again here. Now these are sloped roofs. Here they've gotten plywood instead of OSB on the inside, but you can also do flat roofs with SIPs. That was an option I considered on this house, primarily because I liked the simplicity of using the SIPs. But with the code update that's being implemented now, it's called the 2021 code, although most jurisdictions haven't put it in yet, there's a big increase in the amount of roof insulation required. Much of the country is going to be required to have an R60 roof, and that means quite a lot of insulation. And at present, the SIP manufacturers, I think most of them only go to like R49 for a roof panel. So to use the SIP panel, I would still have to apply additional insulation on top. It also doesn't, in this case, address how I want to slope this roof, because I want to slope this roof both directions, front and back, or in this case, on this side, we're sloping everything down towards the scupper. But where we're sloping it front and back, I would need to put a ridge beam or do something to accommodate that slope. And with the additional insulation required with the new code, I would still end up having to put insulation on top of the SIP panel. So I decided that in this case, framing is going to be a better route for this design, at least for now. Perhaps in the next couple of years, SIP manufacturers will start producing an R60 panel as well. So I've decided to go with a framed roof, and this is how we're going to frame it. We're going to be using 2x10 roof joists. The left side here is the bedroom wing, and there are internal walls. All we're seeing here is the roof framing itself. We're not seeing the walls, but there are internal walls underneath which will provide some intermediate support to these roof joists. So the 26 feet from the front to the back of the house can easily be spanned with these joists, so long as they have that intermediate support. A 2x10 joist depth means my roof is not going to be too thick, and yet I can still get insulation inside between the joists as well as insulation on top. I'll talk about that a little more further along. So on the right side here, we're over the great room, and it's completely open space, 24 feet from front to back. We don't have those internal walls to provide additional support to the roof joists. So what I've done is I've incorporated two beams going crossways, and then the joists will span 8 feet between each beam. I've placed the joists so that the top surfaces are flush with the beams, and then over all of that we'll get a layer of plywood sheeting, and then on top of that our insulation and waterproofing. Now this means that the beams, which are deeper than the joists, will stick down into the room. You can see that there's a few inches there. We'll take a look at that. That can actually look quite nice if it's detailed well. We'll take a look at that in the finished model. So here's a view of the interior with those two beams projecting down below the main ceiling. I have not done finishes yet on the walls, and I may wrap these beams with a finish wood that extends out a little bit and incorporate some hidden lighting up onto the ceiling. We'll get into that in the next video probably. But anyway, so having the beams exposed on their bottom edges can actually be a plus, make the room look nicer. So that was structure. Let's move on to insulation. We've got the amount required, which I mentioned is going to be bumped up to R60 for much of the United States. It'll be R49 in the rest of the country. We've got, in this case being a flat roof, we're going to be doing an unvented roof design. I'm not going to get into the differences between vented and unvented roofs and the issues that have to be dealt with in this video. That really warrants an entire video all by itself. That's a big issue. But anyway, we're going the unvented route, just so you know if you want to look into it more. And then finally, we have to consider, again, the choices we've got for finishing off the insulation above the roof, because we're doing the insulation in two parts. We can use fiberglass or mineral wool bat or wood cellulose bat insulation between the rafters, but we need to have continuous insulation on the top surface as well. And that is going to be some sort of a foam panel typically. So we're going to look at tapered foam panels versus foam in place. Let's take a look at tapered foam. This is Insulfoam. They're one of the manufacturers of tapered insulation panels. Since we've framed our roof dead level, we need to get a slope on the top surface so that we get proper drainage. And the one way to do it is to use the insulation that's got to go up there anyway. Insulfoam makes their insulation out of expanded polystyrene, and we see a photo of one of their tapered panels here. There are also companies, let's see, this is Module RTS, another is Carlisle, that make tapered panels out of polyisocyanurate. Polyiso, it's called, has the advantage of giving you a higher insulation value per inch of thickness, whereas probably the biggest advantage of expanded polystyrene is that it's a little cheaper to get your total insulation value, even though you end up with a thicker panel. Also, it's considered generally that expanded polystyrene is a little less damaging to the environment in its manufacture compared to polyisocyanurate. But that's a point I'm not going to focus on here. That's something that people really need to look into themselves. Anyhow, Tapered foam panels. This is one very good option for getting the slope that you need on your roof. Now, typically when you use a tapered foam panel, in fact, when you use foam panels, tapered or not, you don't want to just have one layer of panel on your roof. You want to figure out how much you need in total. Let's say, for example, you need to have 6 inches of foam on your roof. You would be better off doing it in 3 2-inch layers. And then you arrange the panels so that the joints don't line up from one layer to the next. That way you don't have any chance of moisture or water vapor or anything getting its way between. Everything is blocked and it gives you a nice solid surface. So when you're using something like a tapered panel, the first panel you put down on the roof deck will be not tapered. And then the next panel on top of that will have the taper and the joints won't line up. Typically what you would do if you're going to go the tapered panel route is to get your contractor to send a diagram of the roof and where you want the drainage to happen. In our case, that would be draining down to each side on this side of the building and draining all the way down into this scupper over here on the right side. So a diagram of this drainage scheme would be sent to the roof insulation manufacturer, and the manufacturer would send you the panels all made up according to your plan, along with the diagram showing how to lay out the panels they've provided. And that's what you see in this image here. So that's the approach of using tapered insulation. We're not going to use that approach in this one. We're going to look at another option. Spray polyurethane foam is an interesting choice that has a lot of good applications. It's got some advantages over panel products. It's got some disadvantages over the panel products. One disadvantage is that it can end up being more expensive. So you have to look at that. That can vary according to the local market. Just depends on who's available in the area. But it also has a number of advantages. When comparing it to panels, you have to keep something in mind. The spray polyurethane foam is not just an insulation, it's also your final waterproofing surface. It gives you both insulation and waterproofing in one product and one step. Whereas with the panels, all you're getting is the insulation. You then need to apply waterproofing over that. Typically that would be something like a TPO or EPDM membrane. So if you're going to compare costs, you need to keep that in mind and compare apples to apples. You need to compare insulation panels plus waterproofing membrane to a spray polyurethane foam system. So Carlisle is one of the bigger manufacturers of spray polyurethane foam, and I want to show you a little photo here. So let's look at this photo here to give you a little idea how it works. We've got our roof framed dead level, totally flat, no slope for drainage. And we've got a few penetrations. There's going to be a couple of skylights. There's going to be some plumbing vents penetrating the roof. Here they've got a vent coming up probably from a hood in the kitchen or something like that. So the roofing applicator comes in. He's working on your dead level surface. He's got his chemicals ready to go, and they're basically mixed on site and sprayed on the surface all in one step. So it's like manufacturing a foam panel, but it's not done in a factory and then cut to size. It's done in place on site. And as he does that, he has the ability to spray that foam up onto the edge, for example, the edge of the wall here, or up the sides of the pipes, around the bases of the skylights. All of these areas that would otherwise have to be flashed separately, they're all integral with the foam. It's all done in one step, and it's all continuous. There's no breaks. So all of your flashing is taken care of. The finished surface of the foam itself, once it's all cured, is also waterproof. I think that they actually apply a layer, a final layer, which strengthens the waterproofing characteristics and makes it a little more durable for being walked on. But basically, you have a waterproof surface that's continuous, including flashing around all your roof penetrations. It can be walked on if it's going to be walked on infrequently, just for instance to go up there and sweep the leaves off the roof or something. Then you can get a basic package. If it's going to be walked on a lot, for instance, if it's going to be a roof deck outside a second story bedroom and you want to be able to go out there and put a chair out there and sit and enjoy the sunshine on the roof deck, you can get the top surface additionally strengthened. You can walk around in high heels if you want. But of course that will be an additional cost. That's like a step up. So these are roofing options, and we're going to go with this spray polyurethane foam roof on our project. I'm just going to talk briefly and not go into a lot of detail about what happens to the water once it's off your roof. We have two different conditions here. We've got the main roof, which has got a parapet around it, the roof over the bedroom wing, which has got a parapet around it, so it's all contained around all four sides. And we've got this main area sloping down towards us, and then on each side, a small triangular area that brings the water from the sides down also. And all that water converges right there. So we're going to need to integrate what's called a scupper. It's going to be, I haven't drawn it in yet, but it's going to be in this hole here. And it's basically a sheet metal shape that fits inside there and directs the water as it comes down into this downspout. And then the downspout will bring it down to the ground, completely contained. And I haven't shown it on the model here, but it needs to go into a pipe and taken away from the house. It cannot drain against the base of the house. You do not ever want to drain your gutters at the base of your foundations. Get them a good 10 feet away. So that's what we'll be doing on the bedroom wing side. Pretty straightforward approach. Just requires a little careful detailing around this hole here. Your local jurisdiction might require that if you have a scupper system, that you also have some kind of an overflow somewhere, so that if the scupper gets clogged up with leaves and the water builds up, there's another way out for it. The great room side of the house is a little bit different. We've got half of the roof sloping to the front and half sloping to the back, and we've got what's called an open edge, so it can just drain right off the edge. Now we don't want it dripping down the face of the wall, so I've placed a gutter that wraps around that open edge. And I'm going to specify that the gutter be given the same finish as what we're using around the window, so that it all makes a nice looking, well-planned composition. Nice finished look there. Advantage of a gutter is that you're not going to have any chance of leaves clogging it. Well, there's a small chance, but you just, clean your gutters twice a year. Do that anyway, and avoid having trees hanging over the roof of your house. Anyway, once you've got the water into the gutters, we still need to get it down to the ground. And I wasn't happy with using just a typical downspout, solid pipe downspout. There was no place to put it that looked right. I tried one here, didn't look good. Tried one at the other end, didn't look good. So I decided to go with a rain chain at the corner there. Same thing, that rain chain is going to tie into a pipe at the base of the wall and carry the water away from the house. But I think this looks a little nicer, looks a little more planned. And I also needed to do something for these little porch roofs. There's a porch roof over the entry, and there's another over the back where the master bedroom has its own little deck. So rain chain I thought would make a good solution. Now, in my experience with rain chains, a chain does not do the job. We call them rain chains, but I do not ever use an actual chain type system. What I have found is that when you need it most, which is when you're having a big storm and there's lots of wind, the water just simply doesn't cling to the chain and gets blown all over the place, including all over the face of your house, which is the whole point of what we're trying to avoid. We don't want the water running down all over the face of the house, especially when it's been concentrated through a gutter onto a chain. So what I look for are types that have some kind of containment to slow the movement, to slow the drainage and contain it better. So there are quite a few out there. Lots of nice choices out there. I like this one because they're kind of like funneled, so they really do keep the water contained. Well, that pretty much wraps up what I have to say about rain chains. Lots of choices out there, lots of beautiful examples. Just keep in mind when you need them the most, when it's going to be windy with a lot of rain, you don't want your rain chain to fail you. Also, make sure that it's well secured at the bottom and drains into a pipe that carries the water away from your house. Well, that covers item 4 in our list today: waterproofing, sheet membranes, and flashing. Integral with the waterproofing, so the first one would be using the tapered panels with a sheet membrane like EPDM. And the second is what I'm going to opt for on this design, which is the spray polyurethane. And then finally, we touched on gutters and downspouts. I hope you all found this helpful. Let me know if you've got any questions or thoughts of your own on these subjects. I really welcome people's comments and suggestions as well as questions. I think this is the 3rd episode? So what are we going to be working on in the 4th? In the 4th episode, I guess I'll be tying up all the loose ends on the design and showing you how I transfer the model from SketchUp into Layout to actually make our construction drawings. Hope you enjoyed this. Remember to click the like button, subscribe if you haven't already, and I look forward to seeing you at the next video. Bye-bye.